Hello everyone, welcome to UNC virtual class. I am Prangyalin Sahoo, lecturer of Computer Science Department, and today's lecture I am going to discuss one of very important core part of the computer graphics field, that's your two-dimensional viewing. So here is a table of contents which I will discuss in today's class one by one. So now to start our initial concept, that's your the viewing pipelining. So what is viewing pipelining? Generally in case of two-dimensional viewing, we have to use whenever we have to providing any types of image or any types of object that will be very complex in size and that may be very large. In this case, how all over the output devices screens to be adjusting all over the pictures and viewing all over the images in an efficient ways that to be possible by using your 2D dimensional viewing concept. That means, as you know, suppose the user to be needs for executing or for viewing any types of large images, but here all over the output devices screen size that to be very small. So how all over this screen output devices to be viewing all over the images, whatever the large complex images in an efficient way on our monitor screen on our output devices, that to be normally used one concept that's to be called as 2D viewing. Okay. But in case of 2D viewing, whenever we have to need it for creating the accurate and efficient pictures, in this case it uses one type of world coordinate systems. That means in case of 2D viewing pipelines, whenever we have to viewing all over the images in an large ways, in an complex ways, that pictures to be placed in one coordinate systems that to be called as world coordinate systems. That means initially whenever we have to providing all over the object elements and it's all over the attributes for creating the given images on the output screens. But in this case, in second figures, that's to be defining. Suppose your monitor or output screen devices size that to be normally very small as compared to your images you have to provide it. So how all over these world coordinates elements that to be converted on the format of our devices coordinate systems for viewing all over the pictures in an efficient ways, that all over the things to be normally carried out by using the technique of the viewing pipelining. That means here in case of world coordinate systems, it uses one type of tools that's to be called as normalized device coordinate systems, and by using that normalized coordinate device systems all over the pictures that to be very efficiently converted as the screen size to be provided in the output elements. Suppose in case of world coordinate systems, when we have to converting all over the device coordinate pictures, it to be provides one type of rectangular box. As we know, every output devices elements that to be normally viewing all over the pictures elements by consisting number of dot points, and generally their dot points to be normally looks like your rectangular box. In general way, if we express the 2D viewing concept to be used, whenever the user to be viewing any types of object that to be very large in size, but here the output devices screen is very small. So how in an effectively way all over the images pictures to be viewing on the output screens. So in this case it uses one technique that's to be called as 2D viewing. Generally, as we know, suppose the user to be needed for creating any types of large images, but when the images to be created, after that when the user to be needed for displaying all over the particular images on the output devices, here some partial images to be viewing up, but other some object that to be disappears. So in this case it uses one technique that's to be called as 2D viewing. Here in this case when initially the pictures to be created, in this case it to be uses one concept that's to be called as world coordinate systems. That means here the initial object to be initiated on the screen by transforming all over the model transformation coordinate to the master coordinate format, that is to be called as world coordinate systems. And in this case when the world coordinate systems to be created, after that it to be provided one type of rectangular box which is parallel to the that's your world coordinate systems. When the world coordinate system that to be consisting of one rectangular box which is to be parallel to the world coordinate systems, after creating all over the world coordinate systems, it to be uses one tools through which all over the world coordinate systems to be easily converted as the device coordinate to be provided. That means as the device size. As we know, the device size is different from one to other. That means here in this case it uses one technique that is to be called as normalized Windows coordinate systems, through which all over the particular rectangular portions, all over the informations that to be converted on the format of device coordinate systems. So that is to be called as 2D viewing pipelining. That means here we have to defining the viewing transformation in several steps. That means a viewing transformation using standard rectangles for the windows and viewport. That means initially whenever we have to designing the windows coordinate elements, all over the images elements that may not be fit the devices elements, but initially that to be created by consisting model coordinate to master coordinate systems. After that it provided one rectangular box, and by using that rectangular box it uses another tools that to be embedded with the world coordinate system, that is to be called as normal coordinate devices systems, through which the pictures to be created as the format the monitor screens to be provided, then the pictures to be effectively view up. So that is to be possible by using your 2D viewing pipelining concept. Now the question arises how the internal processing to be possible by using your 2D viewing pipelining concept. As we know, the 2D viewing pipelining concept, the term pipelining means all over the data that to be executed one after another. That means whenever the image to be created of to Windows coordinate system to the device coordinate systems, here all over the different methods and different elements that to be executed on sequential format. That means the next step to be executed by acquiring the previous state's output elements. So that here it uses one concept that's to be pipelining. That means when that to be converted from world coordinate to device coordinate or viewing coordinate systems, in this case different types of sequential steps to be carried out. The first one is that you construct world coordinate scene using modeling coordinate transformations. That means as I have to express, the world coordinate system means when initially the user to be providing all over the methods, rules or protocols through which the picture to be created as the normal data format. After that it to be converted for displaying all over the data elements on the Windows coordinate systems by converting the model coordinate elements to master coordinate systems. So that is to be called as world coordinate systems. When the world coordinate system to be converted, then it goes to convert world coordinate elements by using your viewport. That means here it uses one technique, that's your normalized coordinate devices elements. By using one rectangular box, it to be created as the format of monitor screens. Then after that it to be mapping viewing coordinate elements in normalized viewing coordinate devices. That means as we know, the monitor size that to be different from one to other devices. So that here first the world coordinates to be providing one rectangular box, then by using the normalized devices viewing coordinate technique, it to be converted as the particular monitor screen size. Then when the x coordinate, y coordinate that to be mapping as the format of view coordinate elements, then it goes to the map normalized viewport device coordinate. That means the accurate picture portion element here to be displayed. So by using that 4 steps and sequentially one after another, in this case the viewing pipeline concept to be providing the effective pictures. So that is to be called as process of viewing pipelining concept. So now goes to the next concept, how all over the particular Windows coordinate pictures elements that to be converted on the format of viewport, through which the device viewing all over the outcomes on the effective way. In general way, whenever all over the world coordinate systems to be converted on the viewport coordinate systems, it uses one technique. One is the rotational technique and another one is the translation technique. That means as we know, the pictures to be whenever transmitting all over the coordinate elements from one place to another place, that means the coordinate to be momentum from one location to another location. Here we have used the concept of translations. After translating, if the pictures to be needed for rotating, that means As we know, in case of Windows coordinate systems, it uses one rectangular box as the monitor screen or the output screen by default on the rectangular shape. As the pictures to be dotted points to be normally looks like your rectangular box. So here it uses all over the rotational concept, through which whenever it to be viewing all over the pictures elements, that picture elements to be located on the rectangular box, so that it uses the rotational concept. So check how that to be possible. Here, setting up a rotational wall windows in viewing coordinates and corresponding the normalized viewport. That means here first the wall coordinates, that means here the object to be placed in this direction wedge. But whenever we have to need for viewing these pictures on device coordinate elements on the above part of the output devices as the monitor screen size, here all over the wall coordinate systems elements first to be converting on the format of translation. That means here may be the coordinate elements that to be present on y0 positions, maybe that to be goes in the position of y0.2. So here all over the coordinate element points that to be transmitting. After that, when the coordinate elements to be transmitting as the monitor output screens that to be viewing all over the picture elements on the rectangular shape, so it to be normalized by using your normalized device coordinate systems. When the normalized coordinate system to be finding all over the coordinate elements on the rectangular format, then it to be viewing all over the images, whatever the programmers to be needed view of. So that's the process of the particular converting wall coordinate elements to normalized device coordinate elements. So now goes to the next concept, that's your viewing coordinate reference frame. So what is viewing coordinate reference frame? Generally the viewing coordinate reference frame to be used. Normally the steps or the techniques through which all over the pipelining steps that to be executed in an efficient way without overlapping with each others. So how that to be possible? In this case it uses one technique that's to be called as M of RT, that means all over the particular rotational concept of the coordinate elements to be transmitting by using a rotational into transformation. So here R into T, that means that's your rotational and another one is the translation matrix. And by using the rotational and translation matrix, all over the wall coordinate elements that to be converting their positions to the viewing coordinate format, through which the user to be displaying all over the relevant images as he needs that to be possible. So that is to be called as viewing coordinate reference frame. Generally it to be consisting of two frames. One is the rotational and another one is the translation. So now goes to the next slides, that's sure how that to be possible by using diagrammatically wedge. So how that to be possible? In this case, first the wall coordinate elements, points elements that to be converting on the format of devices elements by consisting one rectangular box. So how the rectangular box to be created? By consisting all over the wall coordinate elements maximum and minimum value. That means here the minimum value to be represented on x axis, that's your wx minimum, and the y coordinates that to be indicated by the wy minimum value. Similarly, in case of views port that to be indicated by the views x coordinate elements and also the y coordinate elements, that's your vy. So how that to be possible? By using the in case of today viewing elements. So here in this case it to be first translating all over the viewing coordinate elements as the coordinate points to be provided of the monitor screen size, then it to be converted by using your particular concept, that's your normalized device coordinate systems. After translating all over the originate coordinate points into other format, then it to be rotating to align axis the two systems. That means as it to be consisting all over the pictures elements on the rectangular format, so it to be rotating all over the pictures element and clockwise or anti-clockwise directions. Then on next step it to be provides another concept that's to be called as scaling mechanisms. So why the scaling concept we have to use? In case of scaling concept, if the programmer to be requires for using for minimizing or for compressing all over the x-axis value and also y-axis value. That means in this case, if the program are to be needed for squeeze up all over the object size on the format of smaller, or maybe that to be required for the expanding the given pictures, that to be possible by using your scaling mechanisms. And the scaling mechanisms to be provides another concept. In x direction, if you have to needed for squeeze all about the data in unidirectional format, that to be also possible. And also that to be provides for simultaneously you have to changeable the direction of the x-axis and also y-axis. So here in case if that to be required after the rotating, the image size to be required for the compressing as the monitor screen size to be provided, that also to be possible by using your 2D viewing concept. So in case of 2D viewing concept, when all over the pictures to be converting on the format of world coordinate 2 up to views coordinate format, it uses 3 frames. One is the translations, the second one is the rotation, and the third one is the that's your scalings. So now goes to the next concept, that's your Windows to viewport coordinate transformations by using your mapping concept. How all over the particular views coordinate elements of the windows that to be viewing on the monitor screen of the users on the format of view coordinate elements. So how that to be possible? As you know, in this case it to be defined initially whenever we have to created by using different types of modeling concept or by using different types of protocol concept all over the particular Windows coordinate elements. Here all over the original picture size of the elements that to be carried out by using 4 components. There sure one is the x-axis of the minimum value of the windows and another one is the maximum value of the x in the windows, and also it contains another 2 variables, one is the y minimum and another one is the y maximum, which describe the maximum size of the given pictures in y directions. So by using these 4 components, how the Windows coordinate elements to be changeable their positions as the view coordinate elements to be provided. So in this case it uses one type of clipping techniques by using a rectangular box. After clicking whatever the pictures portions, the automatically the normalized device coordinate systems to be converting on the format of Vx positions and Vy positions for viewing all over the particular images on the viewport coordinate systems. So that's the format for the Windows to viewport mapping by using the 4 coordinate elements. So now the question arises, how mathematically, as we know the computer only to be understand all over the whatever the data the user to be defining. So generally the user to be defining all over the methods and techniques for its calculations for reducing all over the pictures elements or compressing or expanding all over the pictures elements by using some mathematical concept. So how all over the pictures that to be converting on the format of viewport in mathematical way by consisting the normalized device coordinate systems, so that to be calculated by using one formula. That means here to maintaining the same relative placement for changeable all over the value from coordinate system 2 up to viewport, it to be provides one mathematical concept that's to be called as xb minus xb minimum. That means here xb is the original viewpoint of the origin part, and that's your x minus xb minimum. That means here the minimum value of the by default value of the Windows screen to be started as the device coordinate to be provides, and divided with the xb maximum. That means the x direction of the viewport coordinate elements, the maximum value to be subtracted with the xb minimums. Then after that, in similarly the world coordinate system to be detected by using the formula, that's your xw minus xw minimum. Here xw to be defines the initial by default value of the Windows coordinates minus xw minimum in x direction to be started in which positions, that to be indicated by using your xw minimum, divided by xw maximum, the maximum x coordinate value of the Windows coordinates that to be carried out by using your xw maximum minus xw minimum, which is to be carried the minimum value of the x directions. Similarly, the y coordinates to be carried out by using in these methods, and solving these expressions by using the viewport positions. That means the viewport to be calculated by using two coordinate points, that's one is the x direction and another one is the y directions. And the x directions to be calculated by using your cross multiplications. The formula is xv minimum into xw minus xw minimum into sx. Sx here is the particular scaling factor of the x value, through which the x to be expanded and through which the x to be compressed. And another one coordinate to be find out, that's your yv, that's your yv of minimum yw minus yw minimum into sy. That means the yth directions elements to be calculated by using the formula of rotation, translation and also the scaling factor of y directions, through which when the two coordinate elements we have to detected, after that it to be converted the normalized viewing port elements as the user screen to be provided an accurate way that to be viewing the pictures elements. So that is to be called as Window-To-Viewport coordinate transformation of relative placement calculations. Okay. So now goes to the next concept, that's your Window-To-Viewport coordinate transformation for calculating the scaling factors. How to calculating the scaling factors? The scaling factors to be calculated, that's your Sx equal to xv maximum minus xv minimum. That means only you have to divide the subtraction of the x coordinate value with respect to y coordinate value. That means in this case only you have to calculate the Sx value by dividing the viewport of x coordinate value with respect to the Windows coordinate x coordinate value. And similarly the sy coordinate to be value find out by using the divide of the viewport of yth coordinate with respect to Windows coordinate of the yth coordinate elements. So that's the formula for finding the scaling factors. Now the question arises, how all over the scaling transformations to be possible by using your concept viewport. Here first you have to perform a scaling transformation using fixed position point xw minimum and yw minimum. That means first we have to starting the scaling coordinate elements, that means the rectangular box we have to create it, which is to be parallel to the world coordinate systems by consisting the initial pixel points, that's your xw minimum and yw minimums. After that you have to transmitting by using your normalized concept, you have to transmitting all over the coordinate elements on the format of views code elements. Then that's your second step, that means you have to translate the scaled windows area to the position of the views port as it provided the monitor screens. Then goes to the next step, if any types of character strings to be present in between your particular graphical image, here first it to be maintaining the character size by using the character font, and after that by using the character size line segments, then it to be transmitting all over the number of elements as the viewport to be provides, and by using this concept you have to converting all over the world coordinate elements on the views coordinate format. So coordinate format. So here is the pictures. Suppose these figures to be describes that to be present in a views port on the monitor screens, and that's another one type of pictures to be viewing another monitors of the viewport screens, when we have to need for combining that two into one screen for viewing a normalized format, that to be possible by using your particular concept of viewport coordinate transformation systems. So now goes to the next concept, that's your two-dimensional clipping functions. That means generally the two-dimensional clipping functions that to be provides different types of functions, like your how we have to created the rectangular box by using your clipping functions, how we have to created the original Windows coordinate points that's to be calculated by using the functions, that's your xw minimum functions, and how the question arises how all over the coordinate value we have to calculate it by using the 4 pixel points, that's your maximum minimum value of the Windows coordinate and also maximum minimum value of the views coordinate systems through which the pictures to be created, and also it to be provides different types of rotational translation scaling functions through which all over the pictures to be normalized in an accuracy format, that to be displaying how inaccurate ways on the views port screens. So all over these functions we have to use in case of two-dimensional viewing. So on today's class it's all about, if any doubt or conflict in your mind, then you can ask me with the help of comment box. That's all. Thank you.